Today we're going to be discovering a little more with the line of best fit. You can recall from last lesson, we had a video where somebody was putting oranges in a box. You guys remember that?
Yeah. Oh, yeah.
And each orange weighed about 0.2 pounds. Do you remember that? Yeah. And we also found when there were no oranges in the box, there was some weight there, which the weight was from what? The box. So sometimes in context, a line of best fit makes sense for slope and y-intercept. Sometimes the y-intercept doesn't. That's why we need context. And then we also use that line of best fit to make predictions for other oranges. Do you remember? If we had 11 and 11th orange and if we had 50 oranges. So we're going to keep expanding on that. We're going to build big ideas. And then we're going to use the tool Desmos today to make a line of best fit and also make predictions based on the line of best fit. We're going to start with the card sort. We're going to do 1A, 1B, 1C, kind of one at a time. So don't just roll through this whole slide. You have a bunch of scatter plots in your set that I'm about to hand out to you. And what everybody's going to work on first is arranging those from the best to worst representation of a linear model. So best to worst linear model. So here's the order I have for our best to worst linear models. A and F look pretty interchangeable. A group pointed out, it looks like they're the same, but they have a different y-intercept. C is like super linear, except what? These two things are kind of messing with it. And then D and G, do those seem very linear? Okay, for a shot at the hoop later. Let's see who's really been paying attention this year. For a shot at the hoop during homework time. And you can't just yell, you have to raise your hand. Graph G. Whose favorite graph? Graph G is whose favorite graph? Asher?
Red's.
Nope. Uh-oh. You remember, Finn?
Graham?
No. Yeah.
So we're just saying the name?
Yeah, who, for graph G, who is that favorite graph?
Someone with a G.
Nope. Hadley. Nope. Grant. Nope.
Wait, is it
Oh,
one of those
no.
math people? Is it
Oh,
one
no,
of
it's not a math friend. It's a real person that none of you have probably met before. Do you remember Willa?
those-
Not Mrs. Hicks. Two more guesses, otherwise, Micah?
Mrs. Packard's?
No. Raymer?
Is it Alan?
No. No, it is Soldier Boy.
No.
Look, it's a U. You guys did. Oh gosh, nobody gets extra credit. Okay, but besides Soldier Boy,
Who's Soldier Boy?
check these out. These are not linear, right? So there is a line of best fit you can get with math, but like, does that line even make sense for these situations? No. So we're gonna go now and look at B. We're gonna rearrange these. Least to greatest slope of a linear model. This is important, y'all. First hour kind of missed this. Let's see if you missed it. Well, I didn't highlight it for first hour. That fits the data well. So, least to greatest slope. That fits the data well. Get them organized for me. So here's my reveal. EBAFC. Why did I not include D and G?
How is C the greatest? How is
E the least?
No,
They don't fit. They don't fit a linear model, so we excluded them. So, yeah, Bob.
Yeah, we got like C, F, and A, but in the wrong order.
C, F, and A in the other order.
Because
So they're
they're basically the same.
Yeah, these three are pretty similar. You can.
how is E slope? Not slope.
because it's negative, yes.
Yeah. You can interchange these a little bit. I'm cool with it. All right. Next question. Shh. Hey, reel it back in there. Looking at the back of the room right now.
Hey, come on, Nancy.
Looking at the back of the room here. Last. Least to greatest vertical intercept, aka y-intercept.
This one's gonna be easy.
So we're looking at least to greatest y-intercept, and here is my reveal. Here's what I've got. Boom. ACF, B,
A, C, F.
E.
Yeah, we got that.
I did not use letters G and D because they do not fit a linear model. All right. Here's what's next. In your math notebook is where you're going to document these next parts. We are going to, for each card, down here at the bottom, write a sentence that describe how y changes as x increases and whether it's a good fit or not. So let's do A together. Okay, we'll do A together. So again, what does x do? What does y do as x increases, and does it fit the data well? Let's get some fancy paper going here. This is my favorite fancy paper.
What do you mean fancy paper?
Ooh. So, card A. As x increases, so you're all looking at card A. Actually, let me get a picture of A up in here.
Why?
We'll use a little photo action here. We won't do it for all of them. So there's A. You guys have it in front of you. As x increases, what does y do? Increase or decrease? So y increases. So it's positive, right? Positive slope. And then does it fit the model, linear model well?
Yeah.
Yes.
Yeah. No,
Yeah, I'm going to say it fits pretty well.
It's alright.
It's got a good fit. Okay. All right, so your job is to do this with all the letters through G. Same thing.
Oh.
How does y changes, x changes, does it fit the linear model well? Let's go. Let's roll through. B. As x increased, what did y do? Decrease. And it fit? Great. One little point was kind of off a little bit, but it fit the model very well. For C, as x increases, y increases, and it fits well except those two spots. You guys see those spots?
Yeah.
Okay, D. As x increases, I said it looks like a wave.
Yeah.
Okay. Does that fit a linear model very well? No. Not well. E. As x increases, y decreases, and did it fit well? Yeah, very well, except that one point. Right around I. Okay. And F. As x increases, y increases. Fits really well. Fits really well. And G, Soldier Boy's favorite. It decreases, then increases. Not linear. Not linear. Okay. Next up. This is where you got to make the concerted effort to just go after it. You need to draw a scatter plot of this data. And then draw a line of best fit in your math notebook. A suggestion I would make, you only need one quadrant because everything's positive. And I would go by a scale of 2. You don't need to draw in grid lines, right? You don't have to do the gritty thing. Okay? You can just have blank space and line it up and get it in the right spot in your math notebook. Let's go. All right, so we're going to keep this moving. I actually have to transition here to Desmos. And I'm going to show you a couple things. So I just handed out a Desmos cheat sheet. So we'll take one, hand it down. Micah, I'd like us to... Oh, someone messed up a paper. Oh, dang it. And there's an extra one here. Is this me? I'll probably get that.
Yeah, it's just that one.
Oh, someone messed up a paper clip. Oh, man. So the back of your Desmos sheet that you all got, you will see stuff about line of best fit. The first thing we need to do on Desmos is type in our table and watch this little shortcut. If you type in table, boom, you have a table. The next thing I'm going to do is type in my ordered pairs. So I got 20, 6. My next one, 18, 4.5. My next one, 21, 6.5. I know, it's riveting. Next one, 17, 3.5. Next one, 21.5, 7.5. Next one is 19.5, 6.5. And I got 21.7 and 18.5. And you're like, hey, Mr. Mack, it's not graphing any of those points. Yeah, it is.
What?
Okay, right here. So this next part is how we're going to get the line of best fit. If you look at the back of those decimal notes I gave you on the bottom, do you see that equation that looks a lot like slope-intercept form?
Oh, yeah.
Okay, so we're going to type that in exactly. So y1.
Minus X.
No, that's not a minus. See that little squiggly?
Oh, yeah.
That's like the top left corner of your keyboard, and you have to hit shift. Boom, there's a squiggle.
Shift.
Okay? And then m, x1, plus B. And check out that line of best fit it threw on there. Okay. So the next thing we have to do is come up with the equation for this line of best fit. Well, we need to look at this information that Desmos gave us down here.
That's just y equals mx plus b.
Yeah, so we know that for a line, y is mx plus b. That equation given to us by Desmos says the slope of this line of best fit is 0.78.
0.82.
We're just going to go to 100. And that the y-intercept is minus 9.44. Okay, and in context, back from the slide, I can't go to both things at once. Remember, that table was the weight of ice cream sold at a small store in pounds and the average temperature. Okay? So let's look at what the slope and y-intercept mean in context for this. The slope of 0.78, what does that mean in context?
The amount sold for each pound.
That is, the amount, an additional pound of ice cream. So the slope, we'll write that down, 7.8 means an additional pound of ice cream is sold every 0.78 degree increase. And that'd be good for a business to know, right? Because they could make plans based on like what the weather's going to be, right? If they're selling, if they're an ice cream place. But that's what this slope right here says. It says, again, an additional pound of ice cream is sold every 0.78 degree increase. And that makes sense. As it gets warmer, they sell more ice cream. What does the y-intercept mean?
It's like the base of what people buy it at.
That's the y-intercept, right? Right here?
So is that like the minimum amount of degrees?
Okay, so what is 0 is the pounds of ice cream. So that means that no ice cream sold. When the temperature is negative 9.44 degrees. Does that make sense in context?
Yes.
Yeah, it's probably.
That's probably a little bit colder than people.
Or you could say maybe not. I don't know. The grocery stores in Michigan, right? Snowing cold. They still sell some ice cream, maybe.
Yeah.
That one could kind of depend on how you explained it.
I would definitely ice cream in front of a fireplace.
Ice cream in front of a fireplace. I like where you're at there, Bob. Yeah. So maybe it could make sense in context. It makes sense that if it's really cold, they're not going to sell much ice cream, right? That makes sense to me. All right, we're going to do the lesson summary, y'all. Actually, I want to do one more thing. Let's say what the temperature would have to be, because I kind of want to apply this line of best fit. What would the temperature be if we sold 10 pounds of ice cream? Because do you guys notice like there's no data points over here? Do you guys see that? Okay, so 10 pounds of ice cream, let's figure that out. If we did 0.78 times 10 pounds of ice cream minus 9.44, what would the temperature be? Throw it in the calculator.
Negative
1.3.
I think it's 1.6.
That's what I said. It's 1.6. Negative 1.64. 1.64.
Okay, so let's go with the 1.6. Here's what that means in context. 10 pounds sold when the temp is negative 1.6 degrees. Do you think that makes sense in context?
Yes. Yeah. Yes.
It's still freezing outside. So you could be like, well, maybe they still sell some. Maybe there's a heat wave next week, so they're selling some. But maybe there's a reason there's no data right here in our scatter plot, because if it gets cold enough, they just don't sell that much ice cream.
1.61.
Yeah, 1.6 is good. So that one would kind of depend on how you chose to describe it, right? Context matters.
Oh, the reason it doesn't work is because we're rounding.
All right, I'm going to need to switch tabs here.
1.67. No, 1.617.
Here we are. Lesson summary. When you are done with the lesson summary, go grab your homework out of the top basket under the monkey head.